Okay. Elastic collision is one where kinetic energy as well as momentum is conserved. You can put the conservation of kinetic energy and the conservation of momentum into two equations and do some eliminating of variables, and you find that in that case, if V1 and V2 are the velocities of the object before collision, U1 and U2 are the velocities after, that the relative velocity, the velocity you'd see if you were in this object with this object coming at you. Okay, so imagine you're driving down the road at 60 miles an hour and this guy's coming at you at 70 miles an hour. You see him coming at you at 130 miles an hour. If you have an elastic collision, which is actually more violent than an inelastic collision as far as what happens to your brain as it sloshes around in your skull. But if you have a totally elastic collision, then you're going to see this guy going off at 130 miles an hour. Going to be approaching at 130, leaving at 130. Now you're going to be going this way and he's going to be going that way, but the relative velocity is still going to be 130 miles an hour. But it's going to be reversed, so that V2 minus V1 equals U1 minus U2. So you got this really easy equation if you just remember to use it, and remember that idea, because you're going to get screwed up. Is this a V or a U? Is this a V or a U? Is this a 1 or a 2? Is this a 1 or a 2? If you try to memorize a stupid thing without understanding what I just told you. Okay? In any case, you got this. And I say that means the relative velocity reverses. Now, an inelastic collision, U1 equals U2. That inelastic collision, the two things stick together and go off as one. Okay? Hopefully you've read that. But any interaction, two particleized masses implies that you got equal and opposite impulses and therefore equal and opposite changes in momentum. So, for example, a collision of a 5 kilogram object at 2 meters per second, a 3 kilogram object at negative 3 meters per second. If it's inelastic, assume the final velocity is u. So your change in momentum of the first object is going to be the 5 kilograms times the final velocity minus initial velocity. Common final velocity u minus initial velocity 2 meters per second. Delta P2 equals negative 3 kilograms velocity at the mass of this times u minus negative 3 meters per second. And this is the change in momentum of the second object. This is the negative of the change in momentum. This change in this momentum is equal and opposite to the changes in this momentum. So hopefully you should be primed for that idea. So you set these two things equal and you solve for u, you get 1/8 of a meter per second, and it's very straightforward. Okay? That's really pretty simple. It makes sense. Total momentum before is 10 kilogram meters per second minus 9 kilogram meters per second, easily calculated, which is 1 kilogram meter per second. So that's what you've got to have after. Okay? Should say that's what you got to have after collision. And you can verify that you have the same thing before and after. Now, if the collision's elastic, well, actually, it's kind of simpler. Except you got a U1 and a U2, because the two don't have the same velocity. Here I could use U for the final velocity after, because U1 was equal to U2. Here I've got U1 and U2, so I've got my changes in momentum and my equation that says the change in momentum of this object is equal and opposite to the change in momentum of this one. Okay? Looks exactly the same as this one, except I got two different U's. This is velocity first, afterwards this is velocity second afterwards. Also, relative velocity is the same, well, equal and opposite before collision and after collision. So U1 minus U2 equals V2 minus V1. Calculate that easily, it's negative 3 meters per second. Is that even right? where are the 2 meters per second and 3 meters per second? I wrote it down carelessly. I've got the right relative velocity, but I was right the first time. I don't know what I was thinking. Negative signs again. Most common source of error in the universe. And I won't explain why I think it. Your relative velocity is negative 5 meters per second. Okay? Now, I didn't solve this, but you solve it easily. You could, for example, solve this for U1. It's going to be negative 5 meters per second plus U2. Okay, so U1 we take this up here and we replace U1. Now we just have an equation in U2. U2 is the only variable that's still variable. The only quantity is still a variable in this equation. Okay? Actually, substituted it in the wrong place. Let's come back here and loop around. Substitute it in the actual equation that has an equal sign in it. Okay? Plug it in here, you have an equation in just U2. So you solve for U2, and then you come back here and find U1. You just got this, had negative 5 meters per second, you got it. Very simple. Okay? You got to know the difference, you got to know that this is a case that conserves kinetic energy. I want to say preserves, and I knew that wasn't right. Okay? Make sense?
Yeah.
So that's pretty simple.
I like.
Make sure you know it though.
I like those.